Hi, Barker Keith here with the Lake Lake Travis Rotary Club. I'm at the Kilimanjaro Christian Medical Center in Moshi, Tanzania, the Tanzania Center for Orthopedic Technologies, and we're just starting to print the first 3D printed lower limb socket. I want to introduce to you Brandon Sweeney from Trifusion and let him tell you what's going on. Talk to us, Brandon.
Hey, thanks, Parker. So what we have here is our first 3D printed socket being performed at Kilimanjaro Christian Medical Center. This was from a scan of a pediatric patient, and what we're doing is we're actually physically 3D printing this model based on digital data that was scanned off the patient. So what we're doing here is working on the entire workflow. It's kind of a new technique to make prosthetic and orthotic components, and that is starting with a digital scan of the patient's geometry that's done with an iPad that has a 3D scanner attached to it, and we're working in conjunction with a company called Standard Cyborg to capture that data. They have an iPad app. You just go in and you model the patient's geometry. You upload it to a web program that allows the prosthetist to go in and start to model and shape and smooth and sculpt the device the way they want it. And they can refine it to create the most comfortable socket for the patient. Once that's complete, what we go in and do is we shell it. We create a wall thickness and we add in an adapter that allows us to hook that socket up to the rest of the foot or other components that would be used to make the prosthetic device. So what you see here at the lower portion, we've got the base of the device, and that's going to be bolted onto an adapter. And then as we get up higher here, this is the physical cavity that will contain and hold the socket for the patient so they can walk around on it and support their weight. And what we're working on here that's new and it's just different, it's our secret sauce, is the entire process. It's the workflow. It's the materials that we developed in College Station, Texas. We produce them in-house. It's a high-strength engineering-grade material that's very easy to work with. It's also biodegradable, so eventually when the patient has outgrown this device, it could potentially be composted and break down into the environment. So that's a really nice feature that we have here. The other thing is we have very controlled conditions that we're printing this device in. We have a humidity-controlled cabinet that keeps the material conditioned and ready to print with the highest quality. And then we have worked a lot on the settings that are used to print this device so that we can have the highest quality and strongest part that's possible within 3D printing. As time progresses, we'll be adding on new technologies to this process that will allow us to address both pediatric and adult-based devices. As you can imagine, an adult device needs to be quite a bit stronger and more durable than a device for a younger patient. So we have new technologies that will be coming online that will allow us to address all sizes and weight classes with these printed devices. And I'll let Jared talk a little bit about the clinical aspects that come into play with these 3D printed devices.
So my name is Jared Howell. I'm an orthotist prosthetist from Houston, Texas. I'm the program director at Baylor College of Medicine, running that orthotics and prosthetics graduate training program. So what we're doing here on the clinical side is really training the folks here. They have a large staff of roughly 18 clinicians and about 70 students, more or less, that are learning to become orthotists and prosthetists, but we're introducing them to this technology in a way that will make their lives a little bit better. The hope is that we can use the 3D printing devices to significantly improve prosthetic outcomes here in Tanzania and specifically reduce the cost that it takes to be able to produce these limbs on site. So what I'm here doing is training the clinicians in the modification process, use of the digital scanning equipment, use of the digital modification, and then developing those skill sets that will make them better clinicians with gait training, alignment, and those aspects of fitting a prosthesis. So it's the complement of all of these different things together that will really start to enhance prosthetic care.
Great. Anything you want to tell the people back at the Rotary Club or the people in Austin, Texas?
Love to thank you for all that you're doing to support this effort. This has spurred significant research at Baylor College of Medicine. In fact, we've invested nearly $100,000 into this project and into developing 3D printed solutions for the developing world, as well as enhancing what 3D printed care looks like here in the United States. And so I think that there's a great opportunity to continue to work together, to continue to roll this out across the globe. So thank you again for what you're doing.
So tell us where that prosthetic is going to go in about how many hours we got left on that.
Hour and a half. About an
So
hour.
in about an hour and a half, that'll be done. And then when will we be able to fit Kadogo?
So we will be fitting Kadogo here. This is her prosthetic limb. So within about 2 hours from now, we'll be actually ready to put this prosthesis on. We did create somewhat of an innovative process through our experience here that will be lining that prosthesis with a soft material to protect the limb and provide for it. And so in the course of a couple of hours, she actually should be up and walking on that prosthesis.
All right, good. So, hey, thanks to Jared and thanks to Brandon for getting this project to where it is now. We're about a couple of 3 hours away from actually fitting the first 3D printed prosthetic device here in Tanzania. Watch your clock and watch for more Rotary 3D Limbs Live. Thank you, guys.